Our guest today is a man named Norman Hossack. And if you don't know who he is, you should. We think of front ends on motorcycles, right? We think of telescopic forks. And most of us think that's all there is. But what if I told you that there's a whole different mindset out there on how to handle the front end of a motorcycle? Norman, thank you so much for joining us today.
It's a pleasure. Nice to talk about it.
So for the uninitiated, if you are familiar with alternate front ends, you're familiar with the telescopic fork that's on every single motorcycle in the world. And back when I was a kid, there was very little control over the damping rates of those forks, right? You would go to the brakes, they would just bottom, and it was basically like an oil bath with a rod with 2 holes drilled in it, and that controlled the damping. And in the late 80s especially, we saw this surge in technology that came out, and the one that most of us are probably familiar with is the telelever front end on the BMW, which is effectively like an A-arm with a shock from a car. It's like the front end of a Volkswagen Bug rotated 90 degrees and bolted to the front of a motorcycle, and that's what we were using to manage the front end, to control dive. But you were working on this idea of fixing the front end of a motorcycle long before this ever happened.
Before, when I first sort of bumped into people in Germany and was introduced to the BMW R&D department, I went in there to show them my K100, that's this bike here, and let them ride it. Well, not this particular bike, but another one of this kit. There was, I think, 15 of these made. And they ushered me into a meeting room with their design team, and they avoided letting me go into the workshop because they had blankets over something there they didn't want me to see. And that turned out to be the telelever. So I was showing them how I did it long before they had the telelever on the market. And that was my downfall, because I was selling this kind of bike in Germany through a guy called Rudo, a big German dealer. And most of the customers that bought the bikes were very happy with them, but the telelever came out and took away the market. So as soon as the telelever was in the showrooms, people stopped buying my bike, because this was sort of a kit, an expensive kit. So they could buy a telelever version with the guarantees, with the service principles, everything that went with a full-scale production bike.
So let's go back to the beginning. And what inspired you to start looking at how the front end on a motorcycle worked and how it could be better? What kicked this whole thing off?
Okay. The thing about motorcycles is they're very single line. They're linear. And very small amounts of movement in the steering actually generates the thing to flop one way or the other. So they need very precise axle control. And without that, you're going to get all sorts of wobbles and dives and shakes and things like that. So I saw, when I was at McLaren, because I spent 3 years with the McLaren race team, I saw then that they could actually hold something very stiff and very firmly and with lightweight material. The wishbones on the front of an M23 McLaren Formula One car didn't weigh very much, and they were holding huge amounts of load. I mean, a racing car coming to a halt, that's pushing a lot on the wishbone. And so I said, well, there is a structure around that can do what we need on bikes. And there it was. And I talked to people at McLaren's before I left about, how would you adopt this sort of thing? It didn't go very far because they were all very busy winning world championships and stuff like that. So when I got out of McLaren's, I built this little wire model thing. And I said, I'm going to follow this line. I'm going to use wishbones on the front end of a bike. And that was about it. I worked on starting with this little model, which I showed you. This was sort of the foundation idea. And I could see that you could ride the wheel vertically. And vertically meant non-dive. So it's not an anti-dive system, it's a non-dive system. Telescopic forks are pro-dive because of the angle. But by making the wheel move up and down vertically, you could make it non-dive, which is what I've always done. And The bit about dive and non-dive, pro dive and all that, it was very common language in motor racing. In fact, if you look at Formula One cars now, the front end is severely non-dive, anti-dive. And they do that because they need to keep the clearance between the racing car and the ground in a safe state so that the ground effects work. And so when they put the brakes on a Formula One car, they don't dive now because they've got an anti-dive built-in structure. And I think all those ideas that were floating around, lightweight structure, ball joints, everything like that, I just said, well, do it on a motorbike. So here we go.
Norm, would you be up for explaining the idea of why is this anti-dive? Because I think a lot of folks that come from a telescopic fork, if you think about, hey, there's suspension on the front, the wheel can move up and down in relation to the frame. What makes it anti-dive? How does it not dive? I think that's a question a lot of people don't understand. And I know this probably now you're going to get into like roll center and things like that from cars, but I think that would be a great thing to explain if you can.
The thing about telescopic forks is their 25 to 30 degree angle. And if you put a load, say, straight on the point of the axle, some of that load goes straight down the fork. Or if you see it in reverse, where the bike is moving forward, but the axle is held still, a lot of that forward motion is just absorbed in the fork. So every time you put the brakes on, you are compressing the suspension. And when you compress the suspension, all sort of bad things happen. If you can separate those two events, you have wonderful control. And I think Vernon Glacier proved that on Hossack 1, which is the first bike I built, by people coming back to me and saying occasionally we could see him locking the brakes without it diving and just letting the brakes off and picking your bike up and carrying on. So he could lock the front wheel. You can't lock the front wheel on a telescopic fork because as soon as the wheel locks, that deceleration turns into a lot of energy that has to be released. And that's when you see a bike turns in. When you lose traction at the front end, you're losing traction and there's a lot of energy involved there, so it'll fly away from you. And Vernon could lock the front wheel just tidally so he could change lane. If he wanted to go around somebody, he could tighten up the front brake and move around them. And so, separating the two, to me, was a no-brainer. It's a non-dive system. And I went from that right from the beginning. The second part of maybe that essay is that I was very concerned to know exactly, I'm going to just do it this way. The point in the middle of the front axle is to me the most critical point. I want to know where that is in all occurrences. So that to me, to be able to control that is critical. I need to know when it moves, does it move backwards? Does it move forward? Does it move sideways? I need to know all of those things. And at the time I did this, I think the best front fork system that was tested by the universities in England said you'd be lucky to get a stiffness value of 400 pound-inches. What that means is if you put 400 pounds on the front, the axle will move backwards by an inch. So, or if you put a side load on it, it will move sideways by an inch. So 400 pound-inches is not very good. And that's where a lot of energy is stored because that's actually acting like a spring. If you put 400 pounds in there, it'll push the axle back, but it won't stay there because the 400 pounds will go away and it comes back. And that's where oscillations come from. And of course, the big downside of all of this is it's not just, in my case, I'm concerned about that fore and aft and left and right. With a telescopic fork, because the two members of the telescope have no individual resistance to rotation, their axle can do this as well. And that's probably one of the worst conditions because even a slight amount of movement there is actually steer. If it weaves that way, it'll push this way, or weaves that way. So controlling the front axle to me is the end target of any bit of design. And that's all I set out to do. Just make sure you know where the front axle is.
So when you set off, your main, because there's several reasons why people create an alternative front end from a telescopic fork, right? but your main one was, I want to be able to control what happens, like the axle path. How does the axle move? How does the axle behave under load? That was the main thing you were trying to solve. That was what you were after.
The whole essay of my development was axle control and a non-dive system. The dive system to me was a big problem.
Yeah, and a lot of them that I've seen as well, they sort of lead in with the idea of, I'm trying to solve the problem with telescopic forks is stiction is a big issue that they run into, right? Where based on the load you're putting into the thing and everything kind of binds up and it sticks, right? It doesn't actually just moves and go and track where you want it to. Your system would basically negate that entirely as well because of how rigid the whole structure is.
Well, it's not just that. It's that the only stiction that happens in the joints, which are way back there. And the actual, there's no stiction to axle travel can move as freely as else. There's nothing there limiting it. There's no stiction in that system. Because,
not to mention, you don't have to deal with fork seals anymore.
Well, you do have to have dampers, and there are dampers.
Right.
There's a damper in the front of this bike here. But they're small. They don't have to be big. And the amount of damping you need at the front, to me, seems to be quite little. I've got away with very small dampers on the front without any negative effect. And just to add one thing here, I have a lot of theories which I never got a chance to try because I never had the funds to do stuff. So when I built the first bike, I had a whole lot of different geometries I wanted to try, different conditions, different axle to steering head positioning and stuff like that. I never got to try them. So it turned out to be that the first stuff I put on the drawing was the way it turned out. And with Hossack 1, the first one turned out to be the same bike that won the single cylinder championship in 86, 87, and 88. So it worked. And I was lucky. Yep. But I would I've been real happy to have some R&D funding or some time to play with those things. Never did.
Now, with my understanding of a big chunk of where motorcycle stability, or not necessarily stability, but maybe behavior comes from trail, right? And it can be complicated talking about trail. You have like your rake and your fork offset and like a caster on a shopping cart is the simplest way to try to think of it. And one of the problems with traditional fork, or problems or advantage, maybe how we've evolved riding motorcycles is to solve for trail, right? That we go to the brakes, the forks compress, trail reduces, we leverage that reduction in trail to help the motorcycle change direction. My frustration with telelever is that when there is compression off the front end, trail increases. And so now we have the opposite of what we're accustomed to, right? But one of the beautiful things about Hossack is with these like parallelograms that you could engineer the trail to do whatever you wanted it to do, yes. Right?
Hence my comment that I would love to have done more R&D. Never got the chance. You've hit it dead on there. I would love to have played with that sort of stuff. What I actually ended up doing with Hossack 1 was I sort of looked around at all the bikes that were around at the time. And I thought 250cc was my chance. And I knew what the wheelbase was. I knew what the steering head angle was. I knew what the offset was. And so I said, well, all of those numbers can't be that bad. And I just took up those numbers and went with it. And it turned out to be fine. There might have been a better system for me because I didn't have the dive that they did. So there were areas of experimentation that I never got to do.
Because you think about the complexity of a motorcycle, what's happening, right? As we, on a traditional bike, we go to the brakes, not only is the geometry of the motorcycle changing, with this dive, we're getting where the weight is, where the center of mass is changing, and then how that affects what the rear swing arm's having to do to try to maintain contact with it's unbelievably complicated, right? We think motorcycles are these simple little things, but there's a lot of moving parts.
Yeah, there are. And I think I was very lucky to come pretty close to the right design in the beginning, but I would put it down to luck. I never got a chance to try much. It's just, I was in the right place, fortunately. And all the geometry numbers that I chose straight off seemed to work. And we've never gone back and explored any of that stuff since. And that's, I'm talking about number one, which my first racing bike, which I think I was going around Brands Hatch on that March 1980, something like that. I was racing it myself. So it's wrong for me to make judgments, and I didn't want to make judgments. I wanted other people to ride it. So by 82, I had other people doing the riding for me, and I was looking for feedback. And what I also found was most people seem to want little screw things. I'm just saying this is a general fluffy idea. They want things they can screw and then try again, and then screw and then try again, like on the rear damper or front shock or something like that. People want adjustments. And I came to the conclusion in the end, you're just getting further away from where you should be if you do that. What I tried to do, I would say to a rider, this top wishbone is available for a different size. We can adjust it. But rather than adjusting it, what I would do is take off this one and put the other one on. So you can run the yellow wishbone, which will give you this much of value, or you can run the red one, or you can run the green one. And we can change that at the circuit in 5 minutes. So all of that sort of stuff was there to be experimented with, but I never got the feedback I was looking for.
With the structure, basically, you showed us earlier, and we might be able to get these images put into this, but you showed the structure of the side, the framing part of it, basically the legs of the structure. Yeah, the white. Yep, it looks like a trellis, basically. Yep. The interesting thing about this is right now in modern motorcycling, we talk a lot about when the bikes are leaned over at 60 degrees or more sometimes. When they're leaned over, the suspension, which is meant to work vertically, right, when the bike is upright. When you're leaned right over, you really don't have much in the way of suspension. So what they rely on a lot of times is a little bit kind of the flex of the forks to give them a little bit of compliance over road surfaces. What's interesting about your system with the structure for the legs, you could engineer and design that to have flex characteristics. So in a vertical orientation, it's extremely rigid, right, to transfer all the load through the suspension system. But then as it's leaned over, maybe it has more of a lateral flex to it that you don't have to fight bushings and tubes and things like that. It's a little more engineered.
That's going a bit further down the story than I told you last time. What I'll show you here, I don't know if you can see this. This is the top wishbone from one of the BMWs. This is the kind of thing I was selling in Germany. And this top wishbone was designed to have bearings pushed in there, all silent block bushes. So I had already included the option to put flex into the system when I was doing the BMWs. And we had lots of discussion with the Germans about how much you could buy joints of varying thickness and various conditions. You can buy rubber joints that'll move that way at a different value to if they move that way, sort of thing. So this is the top wishbone of that kit of bikes. And I had designed in right in the beginning the opportunity to make flex if it was needed. And I decided I didn't want it. So that's the top wishbone. That fits into this thing, and that's what the ball joint would be. I don't know if you can.
Oh, that's just a little. Oh, yep. Okay.
So that sits into a housing like that, which sits into the upright. And this is almost precisely how the Germans did it when they saw what I'd done. They wanted to, when I went through their shop, when they were still doing the telly lever, I showed them these joints and said, this is the way the joint works best. And this is the joint that I put on the front of all the BMWs I did. And they ended up doing something very similar to that. And the wishbone was similar as well. I think even the wishbone numbers look similar to what I was doing. So when they did come out with their duo lever, it all looked very familiar to me.
So you're effectively a Hossack front end is what is on a Goldwing still to this day. Is that right?
Yeah, and you could say effectively it's still a double link parallelogram system, but they wanted to include a ball race in the front because they think that low speed steer is important, which might be for a Goldwing. This one here, the BMW, I thought, and maybe I was wrong, but I thought that, if you had a slightly stiff ball joint, you would notice it at 12 mile an hour, just a little bit past walking speed. But when you got onto 20 mile an hour, it'd be nothing. And that's the experience I had, because of this front end is very, very loose. It very, very flexible. I don't know if you could see that.
Yep, we can. Yep.
So, I didn't have a problem with it. But there is another subtlety into why I didn't have a problem and they did. But I won't, that's a bit secret. I won't tell you about that one yet.
You're not going to give us secrets? Yeah, so one of the other factors that doesn't really get talked about a whole lot is the offset number, right? Offset can make such a dramatic difference. It has like an inverse relationship, right? We think of rake, right? More rake gives it more stability or harder to change direction, where more offset gives you the opposite, right? More offset can reduce all those numbers. I was just curious as to like your thinking and trying to solve through those numbers, or, you like looking through your book, which we'll talk about your book more in a minute. It seems like you did have like 2 or 3 iterations of your Hossack 1, the Hossack 2, the Hossack 3. Were you playing with these numbers? Like, how were you considering them in your designs?
Well, with Hossack 1, there was another little secret there. There is, if you see the pictures, there's a joint that sticks out the top of the upright. And that sits into a sort of a U-shaped mounting. But what I also did, more so in the design than I actually put it into practice, is I also made the U-shaped thing the front end of a joint. So it had 2 threaded sections and 2 bolts, and by screwing it in one direction, you could change the trail. Screwing it the other direction, you could change the offset. So I had all of that just with a few spanners, and you could swing this thing back and forward. And you could do all of that with the bike on the ground. You didn't have to take the wheel out or do anything like that. The bike sitting on the ground, you could unlock these things and move trail back and forth. I never got the chance to experiment with all of that. It was, let's get this race done. Let's solve other problems. Let's make sure everything else is working. And then, of course, at the time, I was also trying to build the second and the third and the fourth bike. So, my task at that stage was to let other people ride them and me just get on with building more bikes.
But boy, you can see the advantage of that, right? Like you think about a racing context, this week we're at Brands Hatch, next week we're at Aston, and the week after that, we're at a tight technical little track where you could customize those numbers to put that bike in like the sweet spot based on what it needed to do that weekend.
You could do that. And I thought long and hard about doing that, but I think in the end I concluded that there wasn't enough difference. Whatever the problem is that most people are having, I didn't have, because I'd separated the brake load from the suspension. So the two were not combined in any way. You could brake hard and the geometry could stay where it was.
Yeah, that's interesting, because I think so much of the, like what is the ideal trail number? What's the ideal rake number and things like that for a telescopic fork? It's probably kind of out the window a little bit with this, because we're saying, because the trail number is not static, right? As a telescopic fork pitches, all those numbers are actually changing throughout the stroke of the fork. So it's like, oh, well, it sits at, I want 4 inches of trail. Well, by the time you actually compress the fork, it's way different than 4 inches.
That's the condition with tellies. But with this, I can say that we can do anything we want. That stays separate. They're not interfering with each other. So a lot of energy isn't going into compressing the suspension. The suspension will compress because there'll be weight transfer. The CG of the bike is above the ground, so there has to be some movement there. But all of those numbers that apply to trail and offset will stay where you put them.
Norman, before this interview, I was doing some research, because I've, your system, I'm aware of it, but I hadn't gone into like a deep dive into how it all works really. But the one that I went and looked at, I went and looked at how wishbone suspension works on a sport car, right? Double wishbone system, which is what this is effectively. And I went into understanding, how does roll center work? How does roll center versus center of gravity apply to the leverage of the center of gravity, and all those different factors that go into why you might change this length versus this length of the wishbone. When you were setting this up, were you looking at a lot of those things, or were you more focused on just keeping the path vertical and not worrying so much about that?
The path vertical was for me the ace thing for a motorcycle. The reason you'd see a huge amount of talk about roll centers in racing car books, which is where you'll see a lot of them, is because the roll center is critical to keeping the tire flat on the ground. The purpose in roll center work on racing cars is to get the maximum amount of contact patch when the load transfers. So for them, it's important. For me, I think it's irrelevant. I can make the wishbone system here do almost anything I want. I can even, because I've shown an essay on it, I can even, by changing the wishbones, make this axle move up and down exactly as if it was a telescopic fork, without any of the stiction, but do the same thing as a telescopic fork. I just, depending on which part of the cycle you use, like going right up there, I can make it move just like a telescopic fork. There's endless numbers of opportunity to do R&D here.
Interesting.
Even the BMWs that went to Germany and that Vudo ran, they would send me a frame in London. I would do the conversion, put it all in a box and send it back to Germany. They would build it into a bike. Clearly an expensive way to go. If it had been my choice, I'd have built the whole frame in London and sent them just a complete frame. When they got those things together in Germany and started testing them and running them, one of the places where they really got very happy was at Nürburgring. There's a place, I'm going to try it again, Honschneisse or something like that. There's a bridge and then a climb and then a turn. And the standard K100, which is that thing there, the standard K100 in general had a head shake at that point. That was a standard thing that they've struggled to try and get rid of. But the head shake was common on the K100s. And the problem with the head shake was not only the shake making the driver feel scared. At the end of the shake, the handlebar came to the lever because the shake had pushed the pads back. So for me, I used exactly the same brakes. I don't know if you can see it. Exactly the same calipers, exactly the same wheel. Everything inside that front end was identical to the standard K100. And that thing never nodded anything around Nürburgring. It was clean. Never had a problem with brakes, never had a problem with brakes coming to the bar.
Yeah, it's interesting because with telescopic forks, we've watched the evolution of them for decades, right? Because it's become the de facto standard for most motorcycles, and you've watched over time how they've just constantly tried to refine them and fight the nature of the design, right? So that you've got these tubes sliding in and out, the bushes inside of it, the fact that, like you said, like there's nothing keeping them from twisting within the outer tube. So we now run, it used to be we ran axles that were really kind of spindly little axles. Now we run these great, giant, huge, thick axles that are like a tube. They're structural almost. And then the clamping space on the fork, it's no longer a little clamping space. It's a big, fat, wide clamping space. The tubes have gotten bigger and bigger in diameter, which causes, extra weight, extra cost, worse airflow. All of these things in order to try to fight the kind of the nature of this design, which is this, at the end of the day, kind of a flexy, wobbly design. When we were getting ready for this, I went and did some research, and generally the proper amount of tolerance of the bushes inside of the fork between the inner tube and the bushes is like 5/1000ths of an inch, which is significant. You've got kind of a loose play almost in there, but any tighter than that, and when a rider brakes and the fork compresses and twists, it binds up. And so you sort of engineer in kind of a lot of slop in order to survive and deal with it. So yeah, it's interesting how we've really, Dave and I have talked about this on previous episodes where the motorcycle industry, we talk about it's rebels, it's outlaws, it's all this stuff. It's highly conservative thinking in general, So
Very
I'm sure
conservative.
you've, ran into that quite a bit. So
I mean, the idea that you can take a tube like the front suspension tube and clamp it, that's horrible. That's just not structurally good. And they take up so much aerodynamic space. If you look at it, if you one day you get to look at this thing, you'll find that the distance between the fairing and this upright is about 80 to 100 millimeters, whereas that gap is what was required to have the telescopic forks in there. Yeah, so aerodynamically, this is very streamlined, or could be if the fairing adapted to it.
I have this little Lego toy that is emulating a telelever. And my understanding of telelever is that Lego did a better job because it's actually more of a parallelogram. But to the point you were talking about is you can actually see the rake change as the thing compresses. And I think that goes to the point you were making, that how much control you have when you're dealing with parallelograms, that, you could build a system that would work for a touring application where it didn't matter how much weight you put on the motorcycle, it behaved the same. You could make something that felt like a traditional, telescopic fork motorcycle, or you could probably, which would be really fun to explore, a hybrid of the two ideas.
I published a few essays a few years ago about what could be done by juggling wishbone points and positions. As I've said before, you could make it run just along the same path as a telescopic fork. But you could also, by switching the width and length of the wishbones in their position, you could make something that was pro-dive and then anti-dive. So this axle could start off as being pro-dive to give people a normal feeling, and then make it anti-dive so that when they got into real braking, it didn't dive too much. And hereby lies the biggest problem I had. When I first put it all together, I was just clear that what I wanted to achieve was this vertical path, which meant that most riders getting on it for the first time were not aware that this bike was not going to dive. Alan Cathcart came back after running it around Mallory Park. This is number 3, the third bike. And he said, yeah, but the front brakes are wooden, meaning that he was pulling the lever and couldn't feel the response. And I think that's a problem that I would have to handle, because the non-dive system is the training system everybody lives by. That's how most motorcyclists know how hard they're braking, by how much nod they get. If you take that away, you've taken away a big part of the learning. It takes a little while to get used to it, but you've got to get used to the idea that braking is now not fed back to you through the dive. That is a problem that I faced.
Yeah, that was actually one of the questions I was going to talk to you about, since you've probably had more time riding a Hossack front end than most people. Is the feel, what was the feel? We think of, those of us who ride at a high level of proficiency on traditional motorcycles, Brian races, we teach at the racetrack all the time, that our front brake lever is almost like a feeler gauge, right? The more this changes the geometry, it pushes the tire into the ground, I get kind of this instant feedback. So what was the feedback that you were experiencing on the Hossack front ends?
Well, I never raced that much, so you'd have to ask that question of Vernon Glacier. He could get right up to locking the front wheel, and he was fully in control. He knew exactly where he was. So with a little bit of experience, I think maybe 1 or 2 races, it becomes a non-issue. It's just an issue if you're introducing it to new journalists and new people, and you want them to be impressed by it. First thing they're going to notice is that it didn't nod its head. Matt Oxley rode it at Snetterton. That's Hossack number 3. And I think the first time out, he got a second place. So it didn't take him that long to get used to the idea that, it wasn't going to bury its head in the ground. There still is dive. because there's weight transfer. So there still is some. But what there isn't is force dive by the telescopic forks.
And that whole binding of the forks, the stiction, as that weight is pushing up against all those bushings inside, which, I just see so many advantages in exploring this idea further. Largely because you just have so much control. You could make it whatever you needed it to be.
You can.
Norm, on the two bikes behind you there, those are obviously production bikes that you then fitted your front end suspension system to. Is there much, for most of those bikes, is there much modification at all required to the frame itself or to the interface itself? Or is it a fairly straightforward thing?
In both cases, I first hacked off the steering head and then maybe hacked off on this one, maybe about 3 inches back, and then a lot of stuff at the front engine mount. So the Ducati was, I don't know, quite a cut to get it all off. But the trick I played on that was that the bits I cut off, I reused. So there's no new metal in the frame. The metal that's in the frame now is what was there to start with. And the front end was new, so that's new material. But the frame up to the handlebar pivot is all just about standard at the top. And the engine mounting area, I took metal off there.
Okay.
Almost the same thing happened with the BMW.
Got it. And then with that, was your intent to be able to put the front axle where it was from the factory? So is it basically the wheelbase as it was to start with?
I mean, I could have done, one of my philosophies was not to try and reinvent the world. If you looked at Tony Fowles' work with his Quasar and other things like that, he not only wanted different brake levers, he wanted different handlebars, he wanted different front suspension. So the impulse of the inventive mind is to change everything. I tried to keep everything is where it was. So with the BMW, the tank is unchanged, the fairing is unchanged. The only thing I didn't get to include in there is the steering block. I had to do something different on that front. And almost the same applies to the Ducati. Everything on the front of the Ducati just about is what was there to start with. I didn't want to get into inventing too many bits. I just wanted to stick to my stuff.
So going through your book, you also, and this is really interesting to me because I was completely unaware of this, you came up with a military motorcycle that looked like it used some version of your idea for the front end, but also included basically kind of a single-sided swing arm hub system so they could do faster wheel changes. Could you talk about that? Because that was crazy cool.
You know, the drawings that are in the book were done by Pierre Terblanche.
Oh, really? I got to meet Pierre Terblanche. I've hung out with that man.
Yeah, well, yeah, I'll be talking to him soon.
Right on.
I don't know if you can see it where it is. It's hanging up on the wall behind me. There's 5 different front ends there.
Yeah.
And the one second from that end is that one for the military bike. It has a very standard axle, big bearing, small bearing, adjustment nut, and a castellated thing with a pin in it to hold it all together. And the trick there, of course, is that you didn't need to take anything off the bike to change the tube. You know, a military guy, you're up to your neck in muck and bullets. If you had a puncture, you could throw the bike on its side, break the bead, change the tube, and be riding off without taking a wheel off the bike. That to me was something I thought really should have gone. That worked for me. Not only that, further to that tube, which is fairly long, carries quite a lot of air. So that was a pressurized chamber. And so you could actually, once that was pressurized, you could actually blow up the tire by just connecting it to the tube.
I love that.
That's so cool.
I really did think that was brilliant work, but the rest of the world didn't care. But back in 1981 or 82, I actually built a Ducati for him. So Pierre actually, while he was working in Rimini for Ducati, he had a box of bits which were my Ducati that he paid for. He never built it into a bike, which was sad. But he had all the parts, and I don't know what he's done with them now.
Well, if you're going to talk to him, you need to ask him whatever happened to those.
Yeah.
Yeah, I don't know. He's moved around a lot since then. So, he's been back to Africa, and then he's been back to Barber, and he went into sailing boats, and then he went into, I think when I met him, he just left. Oh, he went to Volkswagen after I met him.
But like you, he kind of had a little bit of a rough go because a lot of his ideas were, they were just too different for the motorcycle community to really accept. He was doing a lot of clever things. So,
He was doing a lot of style things.
Well, he's a designer.
Yeah. I'm not sure he would be seen as the engineer, more the style engineer. Yeah. And what he did was brilliant. I mean, the stuff he did was great. He made a Ducati look quite nice.
Yep.
Well, and it seems like that would be a good ally. Someone who is, willing to take risks on the design side would likely be willing to take risks on the engineering side and try different ideas.
Pierre was designing the Ducati 916 in Rimini when I took this bike there. And Pierre came along with a cardboard template and cut this shape here. He had a template to take that shape, and he put that in the 916 off that bike.
How funny.
That is really funny.
Yeah.
So I've been connected with Pierre for a long time.
Are you willing to talk about when we met last week, we can take
I can only tell you one thing about the telelever.
Okay, tell us our one thing you can tell us about the telelever.
I think it's horrible.
Are you willing to tell us why you think it's terrible?
Okay, it's a hybrid. Okay, I can understand the motivation. You have telescopic forks. Everybody knows that these telescopic forks bend under braking. That's a fairly common perception. And they know that the flex is not nice. So isn't it right to put a wishbone in there and stop that happening? It's a simple thought, and that's what they did. And the first guy to do it was a guy in England, which I saw around about the time I was doing my third bike, I think. That's when it happened. And I think he had reasonable success, but success in those days really depended on how much money you could afford to spend on the bike. And after that, I think many years later, BMW took up that idea. And I now know that BMW, where they were concerned about the stiction of this joint, because it's a plastic joint, they were concerned about that. The telelever now actually has this combined with a ball race in here to free it up, so it runs freer. Well, I could have done that. In fact, I drew that up many years ago. I wanted to put a ball race around this sort of structure section here just to free it up, so make it run at a broader level of usage. But then, like as I've said, there is a trick that they didn't use that I did use on here, which I think makes the difference.
But that's top secret.
That's top secret. Yeah, don't share. So what are you working on now? Do you have any projects you'd be willing to share you're playing with now?
Bicycle.
Oh, bicycle. We're both bicycle nerds.
I don't know.
You're putting a Hossack on your bicycle?
Well, I don't know. You tell me what you think it looks like. It's an aluminium upright. And similar kind of motion.
Are you familiar? There was a company that tried something. It was like I think it's a trailing edge front end. It was called Wave.
Yeah, I've seen that stuff. I mean, there's nothing about this that I would consider original. The only original bit is that the first time I tried to do something in aluminium.
Oh, really? You were doing everything in steel?
Aluminium should not be used structurally. Well, I should correct that. I mean, where you want to carry some real loads, you really need to use steel. But this seems to be, the right level of load to the weight that it's carrying.
the interesting thing with the materials, is your reasoning, Norman, for not wanting to use aluminum just the fatigue of aluminum over time?
Everybody for many years when I was first doing this and this told me I should do it in aluminium. And I was reluctant. I know that in the aircraft industry, you only weld aluminium for panels that cover things. You don't carry any loads through welded structure. I think that's forbidden in the aircraft industry. So I went down that same route. I've done it on this thing because we're dealing with very low loads. And the only person that gets hurt is me if I fall off it. So I can ride this until it breaks. But aluminium to me is, it can be made right, but it's an expensive way. And most people don't really need that because you can make it lighter as well if you made it in steel. My first bike, the Honda, this one here was steel. That was all steel. And it was lighter than everything else around. There was a couple of aluminium frame bikes then on those days. And on average, I think they were 20 pounds heavier. This first bike that I built was very competitive because it was very low weight and everything was steel.
Yeah, the steel, so your front end system, right? Just to come back to that for a second with the steel, the fact that it's steel means you can use narrower tubes, less material in general in order to get the strength that you need. So again, like the airflow idea that we talked about with the telescopic forks, it's an even bigger difference when you can use a stronger, stiffer material like steel for it. So
there's a secondary condition. A secondary condition I should mention. Many shown better here. If you had telescopic forks here, I'm moving off the subject of aluminium. To get up to here, let's say this is the bottom of where the suspension would be. If you go down, there's that amount of naked material that you can't get rid of because you've got to account for the suspension movement. This bottom wishbone can actually go into the wheel below the diameter of the wheel. So it actually brings the structure from, say, here down to here, which means you reduce the leverage quite considerably. Oh, wow. By reducing leverage, it means you reduce load.
One thing talking about the bicycle, as you were explaining the ability to effectively control not only just the axle path, but also the trail behavior and the rake behavior as you go through the suspension stroke, it actually sounds exactly like what we talk about with mountain bikes and mountain bike suspension on the rear end specifically. If you're not familiar, Norman, in the mountain bike world, the rear suspension designs are very elaborate. There is no standard. They're all kind of all over the map. But they talk a lot about axle path curves, and they talk a lot about leverage ratios and how all these things are changing. And, we designed this virtual pivot system in order to get this specific axle path. And
You'll have like an elliptical axle path sometimes.
And some of it is marketing nonsense, right? They're just trying to say my thing's different, so it's better, right?
I would say a lot of it's marketing nonsense.
Yeah. But I think it's fascinating that basically this avenue that you were going down is prevalent. It's very much prevalent in the mountain bike world, which is kind of interestingly a rapidly evolving space. There's always a new design. There's always the next new big thing coming.
Can I tell you the way I do this thing? I see lots of suspension systems and suspension tricks and all that sort of stuff. I am a reductionist. I want to reduce everything to its minimal. And therefore, when somebody says I've got this path or this path, I want to know what the spring rate is at each point. And from that plot, you can draw a plot of axle position and what the spring would be. That's all you need to know. You can make 100 different kinds of suspension. That's the critical bit. That's the question and the answer. It's all there to do with where in the space that is and what the load is on each of those conditions.
Yeah.
And I had the good fortune or bad fortune. When I was at McLaren, we were dealing with a guy from Brabham who had a rising rate front suspension on the McLaren. It first showed on the M19 McLaren. And it's a multiple link thing where one link operates another link. And that was a rising rate suspension. And amidst all the problems you have at the racetrack trying to get things together, eventually they abandoned rising rate because it was too complex. And the drivers were in the middle of whatever their drivers live in. They couldn't make judgments about whether this is good or bad. It was just too difficult to know whether the rising rate system was beneficial or not. And the next generation, M23, they pitched all of that. They got rid of it. It just, there's enough problems going on at the racetrack to not worry about whether the rising rate system's working or not. You just put a damper in there. You know what those numbers are in the curve, and that's the end of it.
Yeah, in the mountain bike world, you'll see marketing material. Maybe we'll send you some links that you could look at later just to check them out. But there's digressive and regressive and all these different systems and behaviors that that's why ours is better and special and whatever. And you got to wonder sometimes how, are you doing this for the rider's benefit or for,
the infinity link, right? Like it uses like this a movable pivot point based on where it is in its stroke.
Yeah.
So that, like that's where you get the elliptic,
I will acknowledge that the bicycle does have one thing which is quite different to a motorcycle. And that's that when a bicycle is being run uphill, the passenger or the C of G is moving up and down. And that is a problem. And I accept that's a problem. But I don't think you can do much about that. But the CG is moving. And that's a problem because the CG, every stroke, the pedal goes up and down. It's doing that. So you're going to compromise at some point about whether the suspension is down or up at this point.
Yeah, some of the systems cause what's called pedal kickback. That like you'll be pedaling and bouncing, and every time the rear suspension moves, it fights you. The pedals are pushing back at you. So it's really fun stuff.
That's the one area where I think bicycles could get complicated. They can run complicated
Right.
suspension. But it is not a motorcycle thing, it's that continuous bumping up and down. That's problematic.
Well, let me ask you this, Norman. If you could change something about the motorcycle industry, given your unbelievably deep history and understanding of it, what would you like to change about what the motorcycle industry is doing?
I would immediately ban superbikes.
Really?
What are they for? What do they achieve?
The racetrack?
That's it. I mean, if you want to have them for a racetrack, that's fine. But they shouldn't be on the public highway. I mean, I think if I was to take my dreams along to some sort of bicycle thing or motorcycle thing, I would want to make a public transport kind of thing that everybody can use, which would be halfway between an aerial arrow and a modern scooter. Something that you could leave outside in the weather, you can get on it and ride to the store. It would be a practical use where motorcycles came from in the beginning. I would sort of go back a long way if that was possible.
That is not the answer I was expecting from you.
Yeah, I like it.
Yeah, I love it.
I mean, I think superbikes have gone way past any practical.
Yeah, 220 horsepower. Brian and I, our bikes that only live on the racetrack, they both make over 200 horsepower.
What are you
can't
gonna do
use
with
that
it?
on any public road.
But you've got a patch of rubber on the road that big.
Yeah.
That's
For
being
200
generous.
horsepower. That matters.
You've written this amazing book. I didn't get to spend as much time with it as I would have liked to. But let's talk about your book because I think folks should be reading it. What I have read so far has been just delightful. What inspired you to write the book, and why should people pick up a copy?
Well, I've been out of motorcycles for 20 years, maybe even more. I mean, the Ducati I did in 2012. And before that, I think the last bike I built, the last bike I even rode would have been 1990. So I'm not in the bike world. And with all the people I know around here in Folsom, I seem to be sitting in bars and dining and telling people stories about what I did. And it's very hard to explain some of the stuff I've done. I mean, so I thought, well, how can I avoid this? How can I get away from it all? So I wrote it all down. It took a long time.
Yeah.
But the other thing about this is I have a very poor memory. I mean, I can't say exactly what date I first rode the Honda, or the first date, or what the weight of the Honda was, or who raced it next. I can't remember that stuff. So I put it in a book.
Well, and you've done way more than just motors. Like we've talked about your Formula One. You went on to do like surgical robotic arms. Like you've done an incredible amount of super interesting things. And so why should people read your book? Not just to like, you know.
I think it's to, maybe I'm irritated by life in the sense that nobody paid attention to what I did. So I thought, well, I'm going to write it down. And they're like,
well, they should have certainly paid attention to what you were doing. Yeah. Where can they get a copy? Where can people order this?
Amazon.
Amazon. It's available on Amazon. It's called Out on a Limb.
Yeah.
It has fantastic illustrations.
It's now available in ebook format.
Ebook format, so you can read it on your Kindle.
Which brings it down to $9 or something like that.
Yeah, I think you would miss out on a lot of the illustrations and the photographs. You know, like, come on, you got photos of Oxley Bauman here racing your motorcycle. You know, like really cool stuff.
Hold on a moment. When you get the ebook, you can actually look at some of the technical stuff and zoom right in.
You can zoom in? Oh, that's really cool. That's very cool.
That's what happens when I try it. I'm not sure that's...
I'm sure.
Yeah. So you can see all the secrets there. You can get right in the middle of it.
Yeah, maybe I'm really hoping that this inspires people to start thinking outside the box and maybe like revisiting some of these ideas. I think they hold so much merit, and I've always been surprised, even though I have my reservations about telelever, I've always been surprised that some of these ideas haven't been explored further. There's just, to my understanding, there's just so much potential. You know, like even just talking about your military bike, and you're like, come on, how many dirt bikers? I was recently in the middle of nothing, and I got a flat tire on the front wheel of a motorcycle. I would have liked to have been able to just like put the thing on, like not have to disassemble the front half of the thing to fix the tube, you know?
I was hoping that if the military, because that was built for the Army, if I could get a foot in somewhere and build that bike commercially, that'd be ideal for the Paris-Dakar. Because I watched the Dakar rally. And the other thing about that is, of course, one wheel did front and rear. So you could carry one spare on the bike way out into the desert. If the front got punctured, you put that wheel on there and carry that wheel back to base. It was all part of the master plan, which didn't master.
Well, Norm, this has been a ton of fun, really fascinating. I feel like I've learned a bunch already. I had some misconceptions that you've cleared up, which has been a lot of fun for me. I very much appreciate you being willing to join us today. We'll definitely have a link for viewers. We'll have a link to Norman's book in the comments or the notes of this video. So definitely check that out if you're able to.
Yeah, thank you so much, Norman. And anything else you would like to add before we sign off? Final words of advice to our loyal listeners.
Only that you guys are doing something for me that nobody else has ever managed to do. You know, a little bit of promotion.
Oh, happy to do it. Happy to. Yeah.
That to me is wonderful because I did 3 BBC films, but the motorcycle industry didn't want to know. They didn't want to see it. So maybe giving it a break, like 30 years and coming back, the world might be a bit more ready to talk to me. I don't know.
Well, I hope so, because I think you just have a wealth of knowledge, and your willingness to share has just been really, I'm thankful. So thank you.
Yeah. All the best.
Excellent. Thanks, Norman.